These are the solutions to the Maths Mock 2024 Paper 1 Ordinary Level exam craft. Question 1A Part 1. A small business is considering purchasing a photocopier. Its price before VAT is €5,500 and VAT is charged at 23%. Find the purchase price of the photocopier. So basically in this question it's asking us to add on 23% for the VAT. So we're first of all going to find our 1%, so I'm dividing by 100, which gives me €55, and I'm timesing that then by 23, which is going to give me the price of the VAT. So that's coming out at €1,265. The question is asking us for the price of the photocopier for the purchase price, so I need to add on my 5,500 that I started with, and that's giving me a purchase price of €6,765. You could also just multiply 5,500 by 1.23. Question 1A Part 2. Its purchase value depreciates by 20% each year for 4 years. Find the value of the photocopier at the end of the 4 years. So for this answer, I'm going to use our compound interest formula, but I'm going to change it slightly. It's going to be 1 minus our interest rate because it's going down. The F is standing for the final or the future value, P for present, and then the I stands for the interest rate, and T stands for time. So the future is what I'm trying to find, or the final value of the photocopier. The present value of it is my €6,765 from part 1. And I'm multiplying that by 1 minus my interest rate of 20%. Turning that into a decimal, it's 0.2. So I divide the 20 by 100. And that's to the power of t, which is 4 years. I then type that into my calculator. And I'm getting a value of €2,770.94. Question 1B. There is also the option of leasing the photocopier for 4 years. The cost is €120 per month before VAT, which is charged at 23%. What would the total cost of leasing a photocopier for 4 years? How much more expensive is the total lease price compared to the purchase price? So we have our purchase price. We have this last part here that's got from A Part 1. So we now need to find what's the cost for leasing it for the 4 years. So leasing it is €120 per month before VAT. So I need to add on the 23% VAT. Now you can do the addition of the VAT now, or you can do it at the very end. It's up to you. I'm going to do it now. So I'm going to take the other way of doing it. 120 multiplied by 1.23. That's the same as dividing by 100 and multiplying by 23. So that's giving me a cost per month of €147.60 per month. The question is for 4 years. 4 years multiplied by 12 because there's 12 months per year, and that's giving me a total month of 48. So I now need to multiply my 147.60, that's per month, multiplied by the 48, and that's giving me the total cost of leasing it, which is €7,084.80. Now the question wants us though to answer it here. Look what it says. How much more expensive is it? So that means I have to take away my purchase price from my lease. So my lease is €7,084.80. Scroll back up here and we get our purchase price. Our purchase price was our €6,765.no. Take them away and that's going to give me the extra cost for leasing. So it's costing me an extra €319.80 to lease it. Question 1C. A sum of money was invested for 4 years at 2% compound interest. At the end of the 4 years, it amounted to $6,500. Find the sum invested. So from our log tables, our formula for compound interest is F equals P times 1 plus I to the power of T. The F stands for final or future amount. The P stands for present, as in today's value. The I stands for interest and T stands for time. So filling this in, it's telling us that it amounted to 6,500 in 4 years. So that's my F, my future value. So I'm putting in my 6,500 for F. The P is what I'm trying to find. So I'm just going to keep that in red here. And I'm multiplying that by 1 plus I, my interest rate. That's my 2%. Divide that by 100 and that gives me 0.02. And my power is my T. My T is my time, which is 4 years. So I'm putting it to the power of 4. I'm going to work out this part here and multiply it by the P. So I'm typing that on my calculator now. So that's giving me 1 plus 0.02 to the power of 4 multiplied by P. So that's 1.0824 P equals 6,500. Now I'm trying to find P. It's stuck to the 1.0824. So I divide everything by that 1.08. So 6,500 divided by 1.0824, and that will get me the P, or the sum invested, the present value, the principal value. Question wants it to the nearest euro, so it's 6,000 and €5.17, but it wants it to the nearest euro, so 6,005 euro. Question 1D, the business owner invested 4,000 for 3 years at a fixed rate of compound interest. At the end of the 3 years, it amounted to that. Find the rate of interest as a percentage to 1 decimal place. From our log tables, our compound interest formula is F equals P times 1 plus I to the power of T. F stands for the final or future, P stands for the principal, the present value, I for interest, and T for time. So it's telling us here the business owner invested 4,000, so that's my P, multiplied by 1 plus I, my interest rate. That's what I'm trying to find. So I'm going to put that in green here. I'm trying to find the interest rate. It's put in for 3 years, so to the power of 3. Now the final amount is the 4,434. So 4,434 euro and 87 cent. First thing I'm going to do here is I'm going to divide both sides by 4,000 because that 4,000 is stuck to the bracket, so it's multiplication. So divide by 4,000 and you'll isolate that 4,000. So on the right hand side, the 4,000s are cancelling out. So I'm left with 1 plus I to the power of 3 equals, and when I simplify that on my calculator, I'm getting 1.1087. Okay, next thing we need to do is get rid of the power here. This power of 3 is causing difficulty, so I need to get rid of that. 2 ways of doing it. You can get the cubed root, this button on your calculator, of both sides, because that'll cancel a power of 3, or you can multiply both sides to the power of 1/3. So that's the way I'm going to do it here. So I'm multiplying both sides to the power of 1/3, because 3 multiplied by 1/3 is 1. So I have to do that to both sides because it's algebra and equations. Whatever I do to one side must do to the other. So that leaves me with 1 plus I to the power of 1, because the 3 times a third is 1. And then on the other side, putting 1.1087 to the power of a third, I'm getting 1.03499. Now on the right hand side here, since it's to the power of 1, I can just take away the 1, and I can also take away the brackets because they're not doing anything now. Then I need to take 1 away from both sides, or move the 1 over. So that's 1.03499 subtract 1 is equal to my interest. And that's giving me an interest rate then of 0.03499. Question wants it to 1 decimal, but its interest rate is always a percentage, and the question said it here to find it as a percentage. So to turn that into a percentage, I'm timesing it by 100. Rounded to 1 decimal place will give us an interest rate of 3.5%. Question 2 is complex numbers. Part A says find the value of Z3 and then hence plot and label Z1, 2 and 3 on the diagram. So they're telling us that Z3 is the conjugate of Z1 plus the conjugate of Z2. Conjugate basically just means change the sign in front of the I. So let's take Z1 first of all. It's minus 1 plus 3i. So the conjugate of that is just changing the sign in front of the I. So minus 3i. My Z2 is 2 minus 4i. The conjugate of that is change the sign in front of the I, so it becomes 2 plus 4i. So my two conjugates are these. The question though wants us now to add them together. So I now need to put them together and add them. So it's -1 minus 3i plus 2 plus 4i. Now you don't need brackets. I'm just putting them into brackets because they're complex numbers. So I have a -1 plus a 2, which is giving me +1. And then I have a -3i plus a 4i, which is giving me a plus 1i. Now the question wants us to plot them and label them. So don't forget to label them as well. So Z1 is back -1 up to 3i, which would be here. So that's my Z1. Z2 is 2 minus 4i. So I'm coming down to here. So that's my Z2. And my Z3 is the one I found here in the box, which is 1 plus 1i. So over to 1 up to 1i. So don't forget that this is the I axis. My Y is my I. So here is my Z3. Part B. Prove that the modulus of Z2 is greater than the modulus of Z1. First of all, let's write down our formula for modulus. So modulus is the square root of a squared plus b squared. So that's our modulus. So let's do out Z2 first of all. So the complex number Z2, given in the top of the question, is 2 minus 4i. The a is the number on its own, the real part. So I'm just going to write down these. My a is my 2, and my b is the number in front of the I, the imaginary part. So that's my a and my b. So if I fill them in now to my formula, it's going to be the square root of a squared, which is 2 squared, plus minus 4 squared. Remember to put that into a bracket when it's on your calculator. So that's giving me the square root of 20. I now need to do the same thing for Z1. So I'm now going to do out Z1 modulus. -1 plus 3i is my complex number. My a is the real part, -1. My b is the part in front of the I, the imaginary part, which is 3. Putting that into my modulus formula, a squared in a bracket plus 3 squared. So that's 1 plus 9, which is the square root of 10. The question wants us to show that Z2 modulus is greater than Z1 modulus, which it is because the square root of 20 is bigger than root 10. So therefore proved. Question 2c, James writes down the following. The modulus of Z1 plus Z2 is greater than the modulus of Z3. Do you agree with this inequality? Justify your answer. Well, to justify it, let's do out our maths, basically, of both sides of that inequality sign. So our modulus, again, similar to part B, is the square root of a squared plus b squared. I, first of all, want to do out the modulus of my Z1 plus my modulus of Z2. So that's the modulus of -1 plus 3i from the top of the question, plus my Z2, which is 2 minus 4i. I'm going to add them together first. So -1 plus 2 is 1, and 3i plus -4i will give me -1i. So I'm looking for the modulus of 1 minus 1i, basically. So that's going to be my a is 1, the real part, my b, the number in front of the I, -1. Filling that into my modulus formula, I have 1 squared plus -1 squared, which is 1 plus 1, which is the square root of 2. So that's the first bit done, the modulus of Z1 plus Z2. Now we need to find the modulus of Z3. The complex number for Z3 is 1 plus I that we found up above. And filling that into my modulus formula of a squared plus b squared, my a is the real part, b is the number in front of the I, which is 1. Filling that into my formula now, I have 1 squared plus 1 squared, which is 1 plus 1, which is the square root of 2. Now looking back to the top of the question says that the modulus of Z1 plus Z2 is greater than Z3 modulus. Now we've got the two of them actually to be equal to each other. We don't have them to be greater than each other. So I'm saying, the question asks us actually, do you agree? So I'm going to say, therefore, no, I do not agree, because z1 plus z2 modulus is equal to modulus of z3, not greater than. Question 2D, find z3 divided by z2 in the form a plus bi. So this is division of complex numbers. z3 that we have from previous part of the question is 1 plus 1i over z1, which is minus 1 plus 3i. I'm just going to put them into brackets. Division of complex numbers means you multiply top and bottom by the conjugate of the bottom. Conjugate meaning change the sign in front of the I. So minus 1 minus 3i. So I now need to multiply out top and bottom. So multiplying out the top of the fraction, I'm going to open up my brackets. First term by second bracket. Second term by second bracket. Divided by the bottom of the fraction. First term multiplied by second bracket. And plus 3i multiplied by second bracket. I now multiply in the tops. So 1 by minus 1 and 1 by minus 3i. Come to the second bracket, same thing again. Minus 1i, and then a minus by positive gives me a negative 3i. All over, sorry, that should be squared, shouldn't it? On the bottom then, minus 1 by minus 1 will give me positive 1. Minus 1 by negative 3i will give me a plus 3i. Second bracket, this is giving me negative 3i. And positive 3i by negative 3i will give me minus 9i squared. On the bottom, you'll see a plus 3i and a negative 3i. They'll cancel out. On the top, I have a negative 3i, negative 1i. Put them together, you make negative 4i. Don't forget then that I squared changes to minus 1. So I'm changing my I squared there to a negative 1. And on the bracket, on the bottom, I should say, the same thing. The I squared will change to negative 1. So tidying up the top, I have minus 1 minus 4i, minus 3 by minus 1 is a plus 3. On the bottom, 1 minus 9 by minus 1 is plus 9. Minus 1 plus 3 on the top will give you 2 minus 4i, I should say, over 1 plus 9, which is 10. Now, I can divide all of those terms by 2. So 2 into 2 is 1, 2 into 4i is 2i, and 2 into 10 is 5. So that's my answer. In the form a plus bi, you can also write it as 1 over 5 minus 2i over 5 if you wish, where a and b are elements of real. Real are just numbers which are negative, positive, fractions, decimals, and so on. Question 3a, solve the following equation in x. So I'm just going to keep the x's on the left-hand side of the equals, and I'm going to bring the constants or the numbers to the right-hand side. First of all, I'm going to multiply in this bracket, which is giving me 6x minus 12 plus 2. Don't multiply the 3 by the 2 because the 2 isn't in a bracket. Grouping the minus 12 plus 2 makes 6x minus 10 is equal to 3x minus 7. I'm going to subtract 3 from both sides, or move over the positive 3x, and it'll become a negative when it comes over, and that's equal to minus 7. Same thing again, bring over the minus 10, it'll become a plus because I'm adding 10 to both sides. So that's 3x is equal to 3. Divide both sides by 3 gives me a value of x is equal to 1. Question 3b, write the following in the form 5 to the power of p. So looking at the top of the fraction first of all here, I'm going to page 21 in my log tables. I'm using the third rule down on the left hand side. So this is the rule I'm using here. And you can see here that in order to multiply the two powers here, it's the same as multiplication. So I'm now going to come to the top here, and I'm going to do the same thing with the 3 and the 6, which is going to give me 5. The 3 is inside the bracket, so 5 to the power of 3 to the 6, which is the same as 5, 3 times 6, which is 5 to the power of 18. So I'm going to put that back into my fraction, so 5 to the 18 over 5 to the 2. I'm now looking at page 21 once again in order how to deal with the division. So I'm looking at the second rule down on the left hand side, a to the power of p, a to the power of q, is the same as the subtraction of the powers. So I just need to subtract my powers. So 5 to the power of 18, 5 to the power of 2 is the same as 5 to the 18, subtract the 2, which is 5 to the power of 16. And the question wanted it 5 to the power of p, so therefore my p is 16. The next part to that question is asking us to solve the simultaneous equations to find the value of x and y. Now I'm looking at cancelling the x's or the y's or both. So it depends on how you want to do your simultaneous equation here. I'm going to do it out twice. If you want to sub in, that's fine. But to avoid any errors being made and losing marks, I'm going to do it out twice here. So in the first, I'm going to cancel maybe the x's. And in the second one, I'll cancel the y's. So to cancel the x's here, my common number is going to be 35. So I need to multiply the top line by a 7, bottom line by a 5. Multiplying that top line by 7 gives us 35x plus 42y equals 28. On the bottom, 5 7s, 35x. 5 8s, 40. 5 8s, 40. I'm now going to multiply across by minus 1, or basically change the signs. So minus, minus, minus. 35x subtract 35x is gone. 42 subtract 40y is 2y. 28 subtract 40 is negative 12. Dividing both sides by 2 is giving you a value for y as minus 6. You can sub that in now to find your value for x, but I'm going to do it again on the right hand side here by cancelling out the y's. My common number here is going to be 24, so multiplying the top by 4 and the bottom by a 3. Top line times 4 is 20x plus 24y equals 16. Bottom 21x plus 24y equals 24. Doesn't matter which line you multiply across by the minus. I'm going to multiply the top by the minus. So that's going to become a minus, minus, minus. Minus 24 plus 24 is 0. Minus 20 plus 21x is plus 1x. And minus 16 plus 24 is positive 8. So 8 is my value for my x. Question 4a part 1. The first three terms of an arithmetic sequence are minus 5, p and 3. Find p and hence show that the common difference is 2. So there's a couple of ways you can tackle this question here. I'm going to use it through, or do it through subtraction of terms. So try and remember that the common difference is always found by taking away terms. So if I was to take, say, term 2 and subtract term 1, I should get the common difference. I could do that another way. I could take term 3 and subtract term 2, and I should also get my common difference. So that means that they are both representing the same thing, i.e. the common difference, so I'm putting in equals between them. So I just want to solve this now for p. So term 2 is p, subtract my first term, negative 5, so double negative there, and then 3 subtract p for term 3 and 2. So the 2 plus, or 2 minuses here make a plus. Solve this for p. I'm going to move over the p's to the left, constants to the right. So that's p plus p because the negative will change to a plus. And that'll become 3 minus 5. So 2p is equal to negative 2. So p is equal to dividing both sides by 2. So p is negative 1. Now the question here wants us though to show that the common difference is 4. So I'm going to rewrite my sequence here. Minus 5, filling in my minus 1 for p. And to get the common difference, I subtract them. So I want to get the difference between the terms. And you can see here that my sequence is going up in a plus 4. So my common difference, my d, is 4. The next part to that question is asking us to find term 12, the 12th term in the sequence. So let's write out my sequence first of all here. It's minus 5, minus 1, 3. Now you can go to your log tables and take down your formula for finding the terms. So Tn is equal to a plus n minus 1 times d. A stands for the first term. Sorry, we're finding T12 here. So I'm going to fill in 12 for n. A is minus 5. My n is 12, subtract 1, and multiplied by d, the common difference. When I work that out, I get minus 5 plus 11 times 4. So minus 5 plus 44, which is positive 39. So term 12, the 12th term, is 39. Part 3, which term in the sequence has a value of 219? So once again, I'm going to my log tables and taking my formula down here for finding the nth term. Now, this value here stands for Tn. I'm trying to find out what number do I put in for n and multiply it out to give me 219. So filling this in here, I have 219 equals a, which is my first term. So I just need to scroll back up here for a second. My first term is minus 5. My n is what I'm trying to find. And my d is my difference, which is 4. If I multiply in the 4 into the bracket, I get 219 equals minus 5 plus 4n minus 4. Grouping the minus 5 and the minus 4 together will give me 219 is equal to minus 9 plus 4n. Moving the minus 9 over the equals will become a plus 9. So 219 plus 9 is equal to 4n. 4n is equal to 228. Dividing both sides by 4 will give me a value for n as 57. Part B. The first 4 terms of a different arithmetic sequence are 3, 7, 11, 15. Find S14, the sum of the first 24 terms. So from my log tables, my formula for the sum of the terms is n over 2 times 2a plus n minus 1 times d. So that's the sum of the first 24 is equal to n stands for 24 multiplied by 2 times a. A is my first term, which is 3, plus n, which is 24, minus 1 times the difference. The difference between my terms here is plus 4. I'm adding 4 to 3 to make 7. I worked that out on my calculator now, and I'm getting 12 over 2, sorry, 12 I should say, 24 over 2 is 12, bracket 6 plus 23 times 4, and that's giving me a sum of the first 24 terms as 1176. Question 5a part 1, find the value of f of minus 3. So we're subbing in minus 3 for x in this part of the question. So everywhere you have an x, you're putting in minus 3. Make sure if you're using brackets here, or sorry, using your calculator, to put it in brackets because it's a negative 3 you're putting in here to be squared. So that's giving me a value of 9 plus 21 plus 12, which is 42. So f of minus 3 is 42. A part 2, find f dash of x, which is the derivative of f of x. So to get the derivative, you're multiplying the power by the number in front of the x, so that's 2x. And then minus 7x differentiates to 7, and you drop the constant to plus 12. So 2x minus 7. Part 3, for what value is your derivative equal to 0? So I'm taking my answer to part 2, my f dash of x, the 2x minus 7, and I'm letting that equal to 0. I'm solving this now using algebra, so add 7 to both sides. I moved this 7 over to become a 0 plus 7, which is 2x is equal to 7. Divide both sides by 2, which is giving me x as 3.5, or you can keep it in the fraction form, 7 over 2. IV, find the minimum point of the curve in the form that, where a and b are elements of real numbers. So we're looking for an x and a y here. That's what the coordinate is made up of. We have the x, we have it from up above. This is your value here. So we're going to be using that as my x part, because that question asked us to solve for x. So all I need to do now is find my value for y. So I'm going to come back here and write down my original function, f of x. I need to scroll back up here, x squared minus 7x plus 12. Now remember what f of x stands for. F of x is another way of writing y. So that's the same as just saying y is equal to x squared minus 7x plus 12. And in order to solve for y, we just sub in our value for x that we got in part 3 up above. So everywhere I have an x, I'm putting in my 3.5 or 7 over 2. And when you work that out on your calculator, you're getting a value for y as minus 1/4. So the question asked us to write it in this form. And we have it in that form. We have it as 7 over 2, comma, minus 1 over 4. Again, a and b are real numbers, so that's why we can have our negative for the top part of the second fraction. B part 1, find the slope of the tangent to the curve at the point 1, 6. remember what slope means. The slope is the same as our derivative, f dash of x. Now our f dash of x from a previous part there was 2x minus 7. So in other words, our slope is represented by the function 2x minus 7. Now they want us to find the slope when x is 1. So therefore I'm just letting x equals to 1 here. So everywhere I have an x, I'm subbing in 1. So that's 2 times 1, which is 2. 2 take away 7 is negative 5. So negative 5 is my slope of the function at the point 1, 6. B part 2 now said hence find the equation of the tangent. A tangent is a line, a fancy word for a line, which touches a curve once at the point 1, 6. So from my log tables, my equation of the line is y minus y1 equals mx minus x1. Writing down my m, which stands for my slope, which is minus 5, and the point, my x1 and y1, is given in the question, which is 1, 6. So filling all this now into my equation of the line, y minus 6 is equal to minus 5 times x minus 1. Multiplying in the minus 5, I'm getting y subtract 6 equals minus 5x, and minus 5 by negative 1 is positive 5. Look at the question here. It wants it in this form. X, y number. So I need to move everything to the left and have it equal to 0. So that's giving me, moving over to minus 5x makes a positive 5x, plus y minus 6, and the positive 5 will change to a negative 5. So my final answer is 5x plus y minus 11 equals 0. Question 6a, find t of 6. So I'm looking at the second function here. The t of x equals x squared minus 5x plus 1. What I'm doing here now is everywhere you have an x, you're subbing in 6. So I'm going f of 6 maps to 6 squared minus 5 times 6 plus 1. So 6 squared is 36 minus 30 plus 1, which is giving me a value of 6 plus 1, which is 7. The next part, B, show that g of x after t is equal to 16x squared minus 60x plus 51. So this is a composite function. And what you're doing here is you're basically, first of all, finding out what g of x is, and then you're subbing that into the t of x. So I know what my g of x is. My g of x is equal to 4x minus 5. I'm now going to sub that into the t of x function everywhere I have an x. So I'm basically trying to find t of, not x, but 4x minus 5. So going back up to my g function, my t function, it's x squared minus 5x plus 1. I'm subbing in 4x, my 4x minus 5. Now in the first one there, 4x minus 5 is to be squared. So I need to multiply that by itself. So 2 brackets. And filling in my 4x minus 5 times 4x minus 5. The second one here, I can multiply in this negative 5 here to give me negative 20x minus 5 by minus 5 by minus 5 is plus 25, and then plus the 1. So multiplying out the 2 brackets, it's first term by second bracket, second term by second bracket. And on the end of it here, I'm putting back in my minus 20x, my plus 25 plus 1, which is 26. Timesing in the brackets here, I'm getting 16x squared minus 20x. Multiplying in the second set of brackets is negative 20x again, plus 25. Then I put back in my minus 20x plus my 26. Tidying this all up now, I have a 16x squared. That's the only x squared on its own, so that stays as is. I have now got a minus 20 is minus 40, minus another 20 is minus 60x. And then finally, I have my constants, which is plus 26, plus 25, which is giving me the plus 51. And if you go back to the top of the question, that's what they wanted us to get to. Part C, solve t of x is equal to 0. Give your answer to 2 decimal places. So getting my function t of x from up above here, it's x squared minus 5x plus 1. and that's my t of x, and I'm now letting that equal to 0. I need to solve this. Normally it would be like our guide number, our 2 brackets, but because they've given us the hint here to 2 decimal places, it's kind of triggering that I should use my minus b formula. So from my log tables, my minus b formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's coming from my log tables. Just writing down, it's a good habit to put down what my a, b and c are before I fill it in. My a, the number in front of the x squared, so that's 1x squared, so 1. My b, the number in front of the x, so negative 5. My c is the constant, the number on its own, which is 1. Filling it into my formula now, I've minus from the formula, then my minus 5 for b, plus or minus the square root of b squared minus 4 times a times c. So filling them into brackets, I have b squared, which is negative 5 squared, minus 4 times a, which is 1, times my c, which is also a 1. That's in a square root, all over 2 times a, which is 2 times 1. Putting that then into my calculator, minus minus gives me plus, and on the top now, that's giving me the square root of 21, isn't it? Over 2. And I now need to do the plus and minus of that. So 5 plus the square root of 21 over 2 and 5 minus the square root of 21 over 2. Question wants it to do decimal places. So that's giving me x is equal to, and x is equal to 4.79 for the positive, and for the negative 0.208, which is 0.21 when it wants it to 2 decimal places. Sorry, I'm just looking at my calculator here again. The first one there is not 4.7. Sorry, my fault here. It's the 2 decimal places, so 4.79. I just forgot to put the 9 in there actually. Section B, question 7. A part 1, find the value of c when f is equal to 59. So we're subbing 59 in for f. So c is equal to 5 over 9 multiplied by 59, we're subbing in for f, minus 32. 59 take away 32 is 27. So c is equal to 5/9 of 27. Brackets mean multiply. So that's giving me a value of c of 15. A part 2. Complete Helen's work so that you find a formula for f in terms of c. So what we're trying to do here is manipulate this so that you have f is equal to everything else. Now they've done the first step for us, so we just have to continue from here. So 5 bracket f minus 32 equals 9c. I'm going to multiply in that 5 into the bracket. So that's giving me 5f minus 160 is equal to 9c. Moving over to 160, or adding it to both sides, so that's 5f is equal to 9c plus 160. To get f on its own, I'm dividing both sides by 5. So that's leaving me with f is equal to 9c over 5 plus 32. So 5 into 160 is 32. Part 3, on a particular day in New York, the temperature in C goes from 25 to 35. Use your answer from part A, part 2, or otherwise to find the range of values for f. So basically what we're doing here is we're taking our formula from part 2 up above, which is 9c over 5 plus 32. And what I'm going to do here is I'm going to sub in c as 25 twice, and that'll give me the range of values for f. So I'm first of all going to do c being 25. So that's going to give me a Fahrenheit of 9 bracket 25. That means multiply plus 32, and the 9c is over 5. So that's giving me f is equal to 45 plus 32. 45 plus 32 is 77. So that's my first value for f. I'm now going to do it out for c is equal to 35. Same steps again. F is equal to 9 bracket 35 plus 32 over 5. Putting that on my calculator, F is equal to 63 plus 32, which is a 95 for F. The question is asking the range of values. So my range of values are going to be from 77 to 95. That's my range of values. Again, fill it in the sections where they want, 77 and 95. B part 1. The robotic lawnmower is currently retailing at 1,500. Find the profit that the company is currently generating at this price. So it's telling us here that X is the selling price. So we're going to sub in our 1,500 euro for X. P is the profit, and that's what they want us to find. They want us to find the profit when the price of the lawnmower is 1,500 euro. So 25,000 times 1,500 minus 10 times 1,500 to be squared. So there are quite large numbers here. My advice there would be to type it straight into the calculator because you're getting extremely large digits and it's coming up as 150000. So it's 6 zeros, so that's millions. So 15, put them in the wrong place there. 15 million is what it should be. So our company is generating 15 million euro. Part 2. The company is worried that the pricing of the lawnmower is not competitive and it is considering dropping the price. At what price should the company sell the product to maximize profit? So that keyword there, maximize, maximum, should link to calculus and differentiation. So if you remember, dy dx equals to 0 is when something is at its maximum turning point or its minimum turning point. So we're going to differentiate our function here for profit. So it's px is equal to 25,000 x minus 10x squared. So I'm going to differentiate that and let it equal to 0, and that'll give me the maximum. So that's 25,000. So differentiating x is x to the 0, so that disappears, minus 2 times 10, which is 20x. I'm now letting that equal to 0 and solving for x being the price of the lawnmower. I'm going to move over or add 20x to both sides. So 25,000 is equal to 20. Dividing both sides by 20 is giving me the value of the lawnmower. So that's giving me 1,250 euro. That's the price that they should be charging. Part 3. Hence, find the maximum profit that the company can make using this new price. How much more profit can the company make now compared to the previous price? So we're basically subbing in our value for x into our function again. Our function is px is equal to 25,000x minus 10x squared. I'm subbing in my 1,250. And again, I go to the calculator here for this. Again, it's quite large. It's 15,625,000 euro. The question then wants us to figure out how much more profit can the company make. So I'm using this figure now, 15,625,000, subtracting the 15 million that I found in the previous part of the question. So the company is making an extra 625,000 euro more in profit. Question 8a part 1. How many grams of Robusto beans are in 2 kg of coffee A? So it's telling us here it's 2 kg. First of all, we need to turn that into grams because the question is related to grams here. So 2 kg is 2 times 1,000 because there's 1,000 grams in a kilogram. So we're looking at 2,000 grams. Now in coffee A, the concentration is 40%. So that means 40% as a fraction is 40 over 100. So we're basically just looking for 40% of 2,000 grams. So 2,000 grams at 40%, or just times that by your 40 over 100, and that is giving us 800 grams. So how many grams of Robusto are in 2 kgs? It is 800 grams. A part 2, Janet mixes 300 grams of coffee A and 500 grams of coffee B. Work out the total concentration of Robusto beans in Janet's new blend. Give your answer as a percentage. So 300 grams of coffee A, so we're looking at 40% or 40 out of 100 again, 40% of 300 grams. That's going to be our first step because that's going to be coffee bean A. So multiplying by 0.4 or dividing by 100, multiplying by 40 gives us 120 grams of Robusto in coffee bean A. Now looking at coffee bean B, it's 28%, so it's 28% of 50 grams because there's 50 grams used in coffee bean B. So 500 grams and 28% of 500 grams. So multiplying by 0.28 is 140 grams. So in total, in her new mix, she has 120 grams from coffee bean A and 140 grams from coffee bean B, which is 260 grams of Robusto. Now the question wants it to give it as a percentage of the total concentration here. So it'll be 260 out of, well, how many grams has she altogether? She has the 30 of coffee bean A and she has 500 from coffee bean B. So that's 800 grams in total. So it's 260 out of 800 times by 100 over 1 to turn it into a percentage. That's coming out at 32.5%. Part 3, Janet mixes 500 grams of coffee bean A and 500 grams of coffee B. What is the concentration of Robusto beans in this blend? Give your answer as a percentage. If we scroll up for a second, we have... sorry, I thought we had the 500 grams of them. We don't. So let's look at... So it's 40% of the 500 grams of coffee bean A here. Let's just start with CA, coffee bean A. So dividing by 100 and multiplying by 40 is giving me 200 grams. And then I'm looking at coffee bean B. So that's going to be 28% is the concentration and it's of 500 grams as well. So 28% of 500 grams is giving us 140 grams. So in total, we add them together. So that's 340 grams in total. Question wants it as a percentage. So the total coffee used here is the 500 grams of coffee A, 500 grams of coffee B. So there's 1,000 grams in total, or 1 kilogram. So it's 340 over 1,000. And I'm multiplying that by 100 over 1 because the question wants it as a percentage, which is coming out at 34%. IV. When creating a new blend, Janet accidentally pours 410 grams of coffee beans instead of the intended 400 grams. Work out the percentage error in this measurement. So the percentage error is the difference over original, or exact basically, and to turn it into percentage multiplied by 100 over 1. So the difference is when we take our 410, what she poured in, take away the intended. So she's poured in an extra 10 grams. So that's my difference. So putting it as a fraction, it's going to be 10 over the original or the exact. So the exact here is the intended, which is 400 grams. Timesing that by 100 over 1 will give us our percentage error, which is coming out at 2.5%. B part 1. If it takes 5 window cleaners 12 hours to clean a section of the windows of the Shard in London, how long would it take 9 people to complete the same job? Give your answer in hours and minutes. Okay, so we have 5 cleaners takes 12 hours. So let's first of all figure out how long it would take 1 cleaner. So if it takes 5 cleaners 12 hours, it's obviously going to take 1 cleaner 5 times more than that. So it's going to be 12 hours times by the 5 because that one person has to do the job of 5 people. 12 5s are 60 hours. Now the question wants 9 people, so 9 cleaners. So to get 9 cleaners, I'm going to divide the 60 hours by 9, which is going to give me 6.6 reoccurring, so 6.66. Now that's 6 2/3 is the same thing. 6 hours 2/3. So it wants it in minutes and hours. So it's going to be 6 hours. 2/3 of an hour, let's just do a bit of rough work here, is going to be 40 minutes. 20 minutes is 1/3, 2/3 is 40, and 3/3 is 60. Another way of getting that is taking 60 minutes and multiplying it by 2/3, or 0. If you want to go like this, either multiplying by 0.6 with the reoccurring. Just make sure that you're putting 6666, not 0.6. So that's giving me 6 hours and 40 minutes. So it's taking the 9 of them 6 hours and 40 minutes. It costs £9,000 to replace 150 panes of glass in this building. Work out how much it would cost to replace 350 panes of glass at the same rate. So let's write it out like an equation here. So 150p, or panes, is €9,000. Let's figure out the cost of just one pane. So I'm dividing both sides by 150 to get the cost of just one pane. So 9,000 divided by 150 is coming out at £60 per pane. Now the question wants 350 panes, so 350p is going to be times that by 350. And 60 multiplied by 350 is giving me the cost for 350 panes, or p as I had it, to be £21,000. £21,000. See part 1, a water trough has a length of 2 meters, width of 1.6 meters and height of 0.5 meters. Find the volume of the trough in centimeters cubed. So first step here is I'm going to turn these meters into centimeters because there's a difference here in the units. The question is given in meters, but they want it in centimeters cubed. So remember that there's 100 centimeters in 1 meter. So in our 2 meters here, it's going to be 2 times 100, so that's going to give 200 centimeters along the base. The width is 1.6 times 100, which will turn that into 16 meters. Sorry, my fault, 160 meters, I should say, not 16. And 0.5 times 100 is giving the height as 50 meters. Sorry, these are all in centimeters, I should say. 160 centimeters, 50 centimeters, 200 centimeters. So volume is given by length, by width, by height. So length 200 centimeters, width 160 centimeters, height 50 centimeters. Multiplying that on my calculator now, I'm getting 1,600,000 centimeters cubed for volume. See part 2, a tap is used to fill the trough. It flows at a rate of 5 litres per minute. Find the time taken for the container to be filled where 1 litre is 1,000 centimetres cubed. Give your answer in hours as a fraction. So what's happening here is, think of the trough and you have a tap or a pipe coming into it here. And what's happening is that the water is flowing into this pipe at a rate of 5 litres per minute. So every minute 5 litres flow through the pipe and into the trough. It's telling us here that 1 litre is 1,000 centimetres cubed. So first thing we're going to do here is find out how many litres the trough holds. So the volume we got above to be 1,600,000 centimetres cubed. If I divide that by 1,000, it'll give me the amount of litres in the trough. So the volume of the trough is 1,600 litres. Now, it tells us then that it's flowing at a rate of 5 litres per minute. So I need to find out how many minutes it takes to fill this 1,600 litres. So I'm dividing it by the 5 litres, which they give us in the question here, 5 litres per minute. So dividing 1,600 by 5 is giving me 320 minutes. So it's taking 320 minutes to fill the trough. Now the question wants it in hours as a fraction. So time minutes per hour is 60 minutes per hour. So 320 over 60 to make it a fraction. And putting that then on your calculator is probably the easiest way to simplify it. which is coming out at 16/3 hours. Again, if you hit your SD button, it's 5 1/3 hour, but it wants it as a fraction, so 16/3. Question 9a part 1. Complete the table below to show the value of h of t for the given values of t. So I'm just going to do out the first one here. Basically what you're doing is you're subbing in the values of 0, 1, 2, 3, 4, 5, 6 into the function here. So the first one is going to be h of 0. So I'm subbing in 0 for t. Again, just make sure that you're using brackets on your calculator. So our first value, h of 0, is going to equal to 5. So I'm filling 5 into the table. And you continue that process for the rest of the steps. And our final one will be 5 once again, filling it into our function. Part 2, draw the graph of the function between 0 to 6. So we're basically just plotting the points. Our points are 0, 5, 1, 15, and so on. And our final one will be 6, 5. Plotting the coordinates, 0 as my time, 5 for my height. I'm going 1 to 15. I'm going 2 to 21. And my last one, 6, 5. Make sure then and draw the graph, freehand sketch of our negative quadratic. Don't use a ruler when sketching a quadratic. Part 3. Use your graph to estimate the maximum height of the ball above the ground. Show your work on the graph clearly. So the maximum height is going to be at 3 seconds, drawing a line up at 3. Again, if you have your ruler in your exam, you should be using your ruler and bringing it across here. So they want us to use the graph, so make sure and draw the lines on your graph. Now that's coming up to roughly 22, 23. I'm just going to go up to my picture here and you can see that at 3 I have it at 23. So I'm going to take the 23 meters there. So using my graph, the maximum height is 23 meters. B part 1, find h dash of t, the differential of h in terms of t. So taking down my function first of all, it's h of t is equal to, I just need to scroll back up here for a second. What was our function? 5 plus 12t minus 2t squared, I think it was, wasn't it? It was. Differentiating the constant 5, it disappears. Differentiating 12t just becomes 12. It's like differentiating 12x. And then the minus 2t squared, 2 by 2 is 4t to the power of 1. So my h dash of t is equal to 12 minus 4t. So hopefully that is not too bad. Scrolling down to B part 2, use your answer from B part 1 to find the time at which the maximum height is reached. The key here is maximum. In differentiation, when you differentiate and let your function, your new derivative equals to 0, that is finding the maximum turning point. So my dy dx equals 0 is your max. Now I know ours is in terms of h and t, height and time, but it's the same principle. So my derivative I've got from B part 1 up above, and we got it to be 12 minus 4t. I'm now going to let that equal to 0 for my turning point. I'm now going to solve that. So I'm going to move over the minus 4t or add 4t to both sides, dividing both sides by 4. So it's giving me a time of 3. Now what we found there is we found the time at which the football is at its highest. Now the question wants us to calculate the height. So I need to come back now and use that time and sub it into my original function. Now my original function, h of t, is equal to 5 plus 12t minus 2t squared. I'm going to sub in that time that I've just found, and that time is 3. So I'm subbing in 3 for t. And evaluating that, I'm getting the height after 3 seconds to be 23 meters. Now, hopefully you can make the link here. If we scroll back up, sorry, my keyboard is appearing there. Scroll back up here, you can see that we already found the time to be 3 seconds and the maximum height to be 23. But we've used calculus to prove that. Scrolling down to part 3, use your answer to B part 1 to find the speed of the football after 2 seconds. Now our answer to B part 1 once again was h dash of t is equal to 12 minus 4t. Now what your derivative is known as, it's your first way of pronouncing it is your derivative, it's your rate of change, it's your slope, and it's also your speed. So what you have here represents the speed of an object. When you differentiate it and find its first derivative, it's known as its speed. Now we want its speed after 2 seconds, so I'm simply just going to be subbing in 2 for t here. So I get 12 minus 8, which is 4, and it's going meters per second. So 4 meters per second. IV, find h double dash t, the second derivative of h of t. So we have our first derivative from up above to be 12 minus 4t. I need to differentiate this again. The second derivative, the 12 is a constant, so it's gone, and minus 4t differentiated becomes minus 4. What does this suggest about the football? So when you get your second derivative, this is finding you the acceleration. Now, in our case, it's going at a negative, so the football is decelerating. Or in other words, the football is slowing down. So if it's a negative, the speed is decreasing. You could also say that the speed is decreasing, or the football is decelerating, slowing down. If it was a positive value, it would mean that it's acceleration, it's getting faster. C part 1, Rory buys a new football. It usually costs €20, but he is charged 17 for it. What percentage discount did he receive? So let's first of all find the discount, and the discount is €3. We're going to work that now out as a percentage. So we're going to take the difference, or the difference between them, which is €3, and I'm putting it over the original price. And the original price is what it's usually costing, which is going to be the €20. So it's €3 over 20 times 100 over 1, which is working out at 15%. So just make sure that your formula you're using here is like difference over original. So make sure it's over the 20 and not the €17. C part 2, Rory also buys a jersey at a cost of $55.35. The price includes VAT of 23%. Work out the VAT on the jersey. So it's important here to make sure that it includes the VAT. So the jersey is 100% for the jersey, and now we have this VAT of 23%, which is included. So the total cost of the jersey is 123%. So in other words, 123% is €55.35. To get 1% on its own, first of all, divide both sides by 123. So that's giving me 1% is equal to 0.45 euro, so 45 cents in other words. The question then wants us to work out the VAT on the jersey. The VAT is 23%, so I'm basically just going to times both sides by 23 to find my 23%. So 23% is equal to 45 cents multiplied by 23, which is coming out at €10.35. Question 10a, complete the table below to show the number of matchsticks required to make each of the first 6 patterns of the above sequence. So the first 2 are done for you here. Pattern 3, well, what have we got here? We've 1, 2, 3, 4, 5, 6, 7, 8 matchsticks. You could draw out the next ones, but you can hopefully see here that it's going up in 2 each time. So I'm basically just going to add 2 each time to get 10, add another 2 here to get 12, add another 2 here to make 14. So that's telling us that it is a quadratic sequence because it's going up in the same first difference. B part 1. How many matchsticks are required to make the 12th or pattern 12 of the sequence? Now you can keep adding on 2 here if you want. Or you could build your nth pattern, your formula here. So our formula here is Tn equals a plus n minus 1 times d from our log tables. Subbing in A stands for my first term, so that's 4 matchsticks, plus n, which is going to be 12, so 12 minus 1, and my difference is 2. So that's going to be 4 plus 11 times 2. 11 times 2 is 22, so 4 plus 22 is 26. So there are 26 matchsticks in the 12th pattern. Now that kind of links us to B part 2. B part 2 wants us to find a formula for Tn, the number of matchsticks required to make the nth pattern in the sequence. So I'm using the same formula here. So I actually, putting part 2 first would have been a little bit easier, but nonetheless, that's the formula. This time I'm not putting in 12. I'm just going to keep it as n. So n minus 1 times d. So d stands for difference. 4 is my a, which is my first term. I'm now going to multiply that 2 in to the bracket. So that's giving me Tn is equal to 4 plus 2n minus 2. I'm going to then subtract that 2 from the 4. So that's giving me 2 plus 2n. So that's my formula for the nth term. Part 3, pattern Q has 128 matchsticks. Find the value of Q. Okay, so remember what n stands for here in this. N stands for the nth pattern, so you'd be putting in the pattern number here, whereas the Tn stands for the number of matchsticks. So I'm going to let my expression here equal to my 128, so 2 plus 2n. I'm solving for n, the pattern number, so I'm going to move over this 2 or subtract 2 from both sides. So that's giving me 128 minus 2 is equal to 2n. 126 is equal to 2n. Dividing both sides by 2 is giving me a pattern number, pattern Q, to be 1n is equal to 63. So its number 63 is the pattern which uses 128 matchsticks. C part 1, find a formula for Sn, the total number of matchsticks needed to make the first n patterns. So from our log tables, our formula for the sum of the terms is equal to n over 2 times 2a plus n minus 1 times d. That's the formula in our log tables. So we're looking for Sn, so Sn is equal to n over 2 times 2a, a being the first term, plus n minus 1 times d being the difference. So subbing in my difference there, I have 2, and subbing in my first term, I have 4. Now it's just algebra tidying that up. So sum of the first n terms, n over 2 times 2 4s are 8, plus multiplying this 2 in now to the bracket. So 2 times n is 2n, and 2 times minus 1 is negative 2. So Sn is equal to n over 2 bracket 8 minus 2 is 6 plus 2n. Now you can leave your answer like that if you want. You can go a step further if you wish. You can put this over 1, multiply in top by top, bottom by bottom. So n by 6 is 6n, n by 2n is 2n squared, all over 2 by 1, which is 2. So Sn is equal to, then I can divide that 2 into the top. So 2 into 6n is 3n. 2 into 2n squared is 1n squared. Part 2, find the total number of completed patterns in the sequence that can be made with 460 matchsticks. So we're not looking for, they haven't given us n, the pattern number. We're looking for the total number of patterns. So what we have here is that the total number, Sn, is going to be 460, because it tells us here that can be made with 460 matchsticks. So that's the total number of matchsticks. So I'm using 460 as Sn, and I'm letting that equal to my 3n plus 1n squared. You're basically trying to solve for n, the nth pattern, the total number of patterns. So you can see here that it's quadratic. So I'm going to move this 460 over, or subtract it from both sides. So I have 3n plus 1n squared minus 460 equals to 0. I'm just going to rearrange it now. I'm going to put the 1n squared first, followed by the 3n, then the constant, minus 460. And I'm going to now put the equal 0 at the back. We now have a quadratic, which you can solve with your minus b formula, your guide number, or your two brackets. I'm going to solve it using my two brackets here. I'm looking for two numbers that multiply to 460 and add to 3. Filling in my n and my n. So multiples of 460 are 20 and 23, and I can make 3 out of those. I'm looking for a positive 3, so this must be a positive 23, and then subtract 20. So I have n is equal to minus 23 when I solve my factors, and n is equal to 20. Now, the maths has given me two answers here, but I'm not going to use the minus 23, because in reality, I can't have a negative number of patterns. So the question is saying find the total number of completed patterns in the sequence. My final answer so is going to be 20. D part 1, the table below shows the number of circles formed by each pattern for the first two patterns. Complete the table to show the number of circles formed for pattern 3 to 6. Okay, so that one's fine. One pattern, one circle. Pattern 2 has 4, which is fine. Here we have 3 plus 4, which is 7. And then in pattern 4, we have what? 4 plus 1, 2, 3, 4, 5, 6. So that's 10. And you can see here that it's going up in a quadratic sequence. No, a linear sequence, I should say. Add 3 each time. So I need to add a 3 and add a 3 here, which is going to give me 10 plus 3 is 13. 13 plus 3, which is 16. D part 2, the area of each of the circles is 2 pi. Find, correct to the nearest centimeter squared, the combined total area covered by the first 14 patterns in the sequence. So first of all, we need to find out the total number of circles in the first 14 patterns. Now this is the combined total, so not just the 14th pattern, but the first 14. So we'd have to add like all of these ones into it as well. So we're using our Sn formula here. So Sn is equal to n over 2 times 2a plus n minus 1 times d. This is in our log tables. So we're looking for the sum of the first 14 patterns. So n is your number of patterns, so that's 14. A stands for your first term, the number of circles, which is 1. And then plus n minus 1, so n is the number we need, which is 14. And the difference between each pattern is it's going up in positive 3. And then you can type that straight into your calculator, but if I work it out, I'm getting 3 13s, which is 39, so 7 times 41, 7 41s is 287. So I have 287 circles. Now the question then wants us find, correct to the nearest centimeter squared, the total area. So a little bit more work to do here. So total area is going to be the area of one of the circles, which is 2 pi. And I'm going to multiply that by the total number of circles that I have. So multiplying that by 2 pi, and I'm getting 574 pi centimeters squared. That's the total area. And that is the end of the paper.